Hello there and welcome to our 2-2 notes, which is solving two-step equations, very fitting. So 2-2 is two-step. Our learning target for today, so learning target is I can solve two-step equations. Go ahead and put your name in that top right-hand corner and today's date. So for our steps for solving two-step equations is always kind of like our one-step locate the variable. And start to cancel or get rid of. So I'm just going to put to get rid of terms farthest away. Okay. And the reason why is because the examples we see today aren't going to be all exactly the same. They'll have some different steps for different examples that we'll have to go through. So the very first step is to locate the variable and to start to get rid of the terms that are farthest away. Step 2, same thing, we have to get rid of the remaining terms. Because once again, different things could be happening. We know how to multiply, and the opposite operation is to divide. We know if whatever's left over is being added or subtracted, we're going to transpose it. And the last little bit is to solve and check. So make sure our variable is isolated alone and check for our solution. So once again, I know the steps there are a little bit different, but just kind of want you to think about, the steps and how to apply them to several different types of examples. So, let's dive right into them. So, example 1. We're given 7m minus 17 equals 60. We're asked to solve this equation, then check your solution. So, step 1, locate our variable. There he is, he's on the left side. And what's farthest away. So 7 is side by side our m, so he's really close. But on this left side, the equal sign, our 17's a little bit farther away. He's out here. So we're going to get rid of our 17. So since he's being subtracted, we're going to transpose him to their side. So 7m drops down, our equal sign drops down, our 60 drops down, and our minus 17 becomes a plus 17. 60 plus 17 is 77. Now, the last thing we got to do to solve for our variables is if they're side by side with a 7, that means they're being multiplied. So the opposite of being multiplied is to divide. Divide both sides by 7. 7's cancel, and m equals 11. Now to perform our check, we're going to have to take the original equation, 7m minus 17 equals 60. Alright, so now we get 7 times our m is going to become 11. So 7, use parentheses for that multiplication, times 11 minus 17 equals 60. 7 times 11 is 77. Drop down our minus 17. Good old-fashioned order of operations kicked in there. We had to multiply before we were allowed to subtract. Now the only thing left to do is subtract. 77 minus 17 is 60. And 60 does indeed equal 60. So we check. We're all set. We'll see our next example. Alrighty, so example 2. For this one, we're just asked just to solve, not to check it. We got 5w minus 13 equals 37. So if you notice, it's really similar to the setup we had in our last example. So if you want to go ahead and try to work ahead of me, go ahead. If you need your steps, just stay right with me. Alright, so we locate our variable first. We got w over here on the right side. We look at who's farthest away from our w on the I said the wrong side there. On the left side. We have our variable w here on the left side. And now who's on the left side with him? We have being multiplied by 5 and minus 13. Now because 5 and w are side by side, they're closest. So that means I'm going to get rid of my minus 13 first. Transpose my minus 13 over there. And now, for the left side, we're going to keep our 5w. 37 drops down, our equal sign drops down, and our minus 13 becomes a plus 13. 5w equals, and now 37 plus 13 is 50. Divide both sides by 5. 5's cancel, and W equals 50 divided by 5 is 10. And we're all set. And if you did want to check it, you could once again just replace W with 10. 5 times 10 is 50. 50 minus 13 is 37. It's all good. All right, example 3. We're given t over 8 plus 21 equals 14. Once again, we're asked to solve this one and to check your solution. So first step is to locate our t. He's over here on the left side. And now we're going to get rid of who's farthest away from him on the left side. So we're being divided by 8. We're being added to 21. The 21's farther away, so we go to transpose him. So plus 21 goes over there to become a minus. So my t over 8 drops down, equals 14 drops down. Plus 21 becomes a minus 21. And now t over 8 drops down, equals 14 minus 21 is a negative 7. Now, t's almost by himself, but not quite there. That fraction bar tells us to divide. So if it's being divided by 8, we do the opposite and multiply both sides by 8. Once again, multiplying by 8 and dividing by 8 are opposite, so they cancel out. We drop down our t equals 8 times 7 is a negative 56. And now we're asked to check it, so we'll know for certain if our answer is right here or not. So we'll go to the original, t over 8 plus 21 equals 14. T is going to be a negative 56 now, so negative 56 over 8 plus 21 equals 14. Negative 56 divided by 8 occurs first in the order of operations because division comes before addition. So negative 56 divided by 8 is negative 7 plus 21 equals 14. Negative 7 plus 21 is 14. So 14 does indeed equal 14. We're all good. All right, next example we have. Once again, where this one's a lot like the one we just saw, and all we're doing is just being asked to solve s over 12 minus 9 equals 11. Go ahead, work ahead of me if you feel confident, and check your answers with me. Make sure you're all good. So first things first, locate our s. He's over here on the left side. Get rid of who's being farthest away. So 12 is directly under him, and then minus 9's out here. So because minus 9 is farthest away, we're going to transpose him, make him a plus. So I'm going to drop down my s over 12 equals 11. Now my minus 9 becomes a plus 9. S over 12 drops down again. 9 plus 11 is 20. And now, if s is being divided by 12, we do the opposite and multiply both sides by 12. Multiplying by 12, dividing by 12 cancels out, and we're left with s equals 12 times 20 is 240. And we're all good. So far with examples 1 through 4, if you take a second and look at all of them, I'm going to backtrack so we can see 2 and 3 together. With the way they're set up, the very first steps for these were to transpose. That's the first thing we did. Oh, something weird's happening there, and I don't know what, but that's okay. So transpose, and then the second step was to multiply or divide to do the opposite operation. So those were the 2 steps for our first 4 examples. Were to transpose whatever's farthest away and then multiply or divide to solve for a variable. When they look like that, those are those 2 main steps. Now some of you may have realized I paused here to refresh our memories about the first 4 examples because we're going to see a different type of example now at example 5. So take a second, sink that in, make sure you're all good. And now we'll change gears a little bit. So example 5. There we go. Oh, maybe one more. There we go. We'll skip that one. Example 5. I really want to see this one. We have m plus 13 over 2 equals 8. Now this one's different from those last ones we saw because one whole side of this equation is a fraction. So this whole thing is a fraction. Now if you think about our rules about getting rid of who's farthest away from our variable, we'll have to think about that different this time. So our m's over here on the left side. 13's the numerator with it, so adding 13 is up top, so they're together. And then dividing by 2 is the denominator, so 2's our denominator, so he's farther away. So we're actually get rid of our 2 first here. So this one we're going to, so if it's being divided by 2, we're going to multiply both sides by 2 to start. And once again, if you multiply by 2 and you divide by 2, the 2's cancel and leave us with m plus 13 equals 2 times 8 is 16. And now we just got to do what we got to do to solve for m. So since it's being added to 13, we're going to transpose m and say m's on the left equals to 16 plus 13 becomes a minus 13. M equals 16 minus 13 is 3. Now, because it is the first one we've seen of this set, we're going to check it. So we always go back to the original. M plus 13 over 2 equals 8. And now, m is going to be replaced with 3. So 3 plus 13 over 2 equals 8. If you remember order of operations, we say because they're the numerator, we do that first. 3 plus 13 is 16 over 2 equals 8. 16 divided by 2 is 8, and 8 does indeed equal 8. We check. We're all good. Now, to really make sure we have this type of example down, we'll see one last one. Example 6. We're given negative 2 equals x minus 4 over 12. Now, first things first, we check to see where our variable is. This time he's on the right side. And we look what's happening to him and who's farthest away. So he's subtracting 4, and they're both on top together, so x minus 4 is the numerator. He's being divided by 12, so 12's our denominator, which means he's farther away here on the right side. So to get rid of being divided by 12, we're going to multiply both sides by 12. 12 times negative 2 is negative 24 equals multiply by 12 and divide by 12 cancels out and leaves us with just x minus 4. Now to solve for x, we're going to say if it's subtracting 4, we need to transpose him to the other side. So I'm going to drop down my negative 24, bring over my negative 4 to make him plus 4, equals x. And now negative 24 plus 4 is negative 20, equals x. Now for this one we won't do a true check, but we will say if we plug it in up here, negative 20 minus 4 is a negative 24. Negative 24 divided by 12 is negative 2. That works. Now, for these last two examples, if you want to make a note of this because it's really important, when one side's a fraction, so whole side is a fraction. The first thing we have to do is multiply both sides by the denominator. Oh, my m got an extra hump there, ator. There you go. And then the second step was to just solve for the variable by transposing, or in some cases it may have more stuff going on, but for this one, all we had to do is transpose for these two. So there's our two steps for these types. So first step is to multiply both sides by your denominator. Second step was to transpose to solve for the variable. And that finishes up with our two-step equations. Thank you so much.